Welcome to the second lesson under Unit 4, Statistics and Probability of the AI/HL math course. Today we'll speak a bit about sampling. It's not the hardest topic, but there is quite a lot to remember, so bear with me. So the first thing we need to do is set out what the two types of data are. So we have discrete data. This is where the data can take on a specific set of values. And continuous data is where the data can take on only, can take on any value. Now, the way I like to think of this is basically by thinking of a number line. So let's say you have a number line here. Not a very good one, but let's say you have the numbers 1, 2, 3. Now, discrete says that you can only have 1, you can only have 2, and you can only have 3. Continuous basically says that you can take on 1.754, 2.5467, 1.65, you know what I mean? It can take on any value. Now, this will make more sense when we look at these examples here. So let's classify them into discrete or continuous. Now, the number of students in a class. This would be discrete. Now, this is because a student is a person. You can only have one person. You can't have 1.5 of a person. You just can't. So it's either one person, 2 people, 3 people, 4 people. Now, the height of students in a class. This is also continuous. Now, this is continuous because height can take on quite a large range of values. So it could be 1.65 meters. Realistically, you can also be 1.6574 meters. You can be 1.54, all of that. Now, the number of books in a library. This is discrete. Kind of going back to the person analogy here, you can only have one book. You can have 2 books. You can't really have 1.75 of a book. Now, the weight of fruits in a basket is continuous. Now, this goes back to the height. Weight can take on many forms. So you can have 10 kg, you can have 10.59 kg, and so on. Now, the temperature throughout the day is, once again, continuous. This is because, once again, temperature can take on many values. You can have 26 degrees, 26.5 degrees, 26.54 degrees. Now, the number of cars in a parking lot. This is discrete. Now, the reason this is discrete is similar to the person analogy. You can only have one car. You can't have 1.75 cars, and so on. Now, the time taken to complete a task is actually continuous, because you can do a task in 60 minutes, you can do it in 60.75 minutes, so on. Now, the number of questions in a test is discrete. You can only have 1 question, 2 questions, 3 questions, 4 questions. You can't have 1.2 of a question. Now, number 9, distance traveled by a car. Once again, this is continuous. Distance is continuous, so you can have 5 meters, 20 meters, 20.54 meters, and so on. Now, the number of siblings someone has is discrete. Goes back to that person analogy completely, because you can only have 1 sibling, 2 siblings, 3 siblings. You can't have 3.5 siblings. It just doesn't really exist. Now, finally, is shoe size. Now, this one is a bit of a tricky one, but it makes sense. So we actually say this is discrete. Now, the reason we say this is because let's say you go into a shoe store. You can only really get shoes in size 5, 5.5, 6, 6.5, 7, so on. You can't really get shoe size 5.25. It just doesn't exist. That's why we say that it is discrete. Now, I hope that made sense. I do advise going online and just finding examples and asking yourself if it's discrete or continuous. But let's move on. So now we got to learn the difference between population and a sample. Now, let's imagine this is a classroom. And all of these dots represent students. So each one is one student. Each dot is a student. Now, what we call a population is everyone in that area. So in this case, the population would be basically this whole classroom. That's your population. That is everything you want to test, right? So in this case, that would be 60. So your population is 60 because there are 60 dots inside this classroom. So your classroom is your population. Now, let's say within that classroom, I wanted to test these students here. I wanted to test these, right? Now, I would then call my sample 12. That is because out of these 60 students in the classroom, I am testing 12 of them. So that is my sample. This you can do with anything. So let's say I just wanted to do these 4 here. That'd be a sample of 4. Now, I hope that also makes sense. Just think of a sample as what you're trying to test and the population as everything around that. So let's move on to types of sampling. Now, this is not the most fun thing. I will not pretend that it is, but you just have to learn them, and it's typically pretty simple because it's in the name, as you'll see. So we have simple random sampling. This is basically where you choose a sample completely at random. So let's make this red. Okay. Let's say we go back to my classroom analogy. You have 8 students in your class, and you go, okay, I'm just gonna randomly pick this person, this person, this person. That is simple random sampling. There is no meaning behind your decisions. You're just randomly picking a sample. Now, convenient sampling is choosing a sample that is easy to reach. Now, imagine this is your classroom. Yes, the board is up here, and your class is set up like this. You have 6 students on either side. Pretend that you are this person here. That's you. Now, convenient sampling would be, because you're on this side of the class, you would pick this person, this person, this person. That is convenient sampling. You're not moving all the way here to pick this person, this person. It's too much effort. So that is convenient sampling. You're doing what's convenient. Now, systematic sampling is selection at regular intervals. So let's say you all lined up as a class, as many do for assemblies. Now, let's say you have 8, 9, 10 students in your class. Now, you are here at the front. Systematic sampling is basically saying, okay, let's say I'm going to pick every second person. So what you would do is you'd pick the second person here. Then you'd pick this one here. Second person here. Second person here. Second person here. And so on. Now that is systematic. It can also be every 10th person, every 5th person. It doesn't matter. But it's just that it's systematic. Now, quota sampling is basically choosing samples with quotas. So let's say you wanted to test gender in the classroom, I guess, but you just wanted male and female participants. What you would do, let's say you had your classroom, quota sampling is basically saying, okay, I want, out of 100 people, I want 50 female, 50 male. So you simply get 50 female, 50 male. That is quota sampling. This could also be 20/80, 25/75, so on. Now, stratified sampling is choosing samples where proportions are maintained. Now, don't get this confused with quota sampling. It is a bit different. Quota sampling basically doesn't really take into consideration the nature of the population. So what I mean by this is stratified sampling. So we do not want that. All right, so let's say your classroom has 100 students. You have 100 students. Now, in your classroom, 25 students are female and 75 students are male. That is just the nature of your classroom. Now, let's say you wanted to test a sample inside your classroom. What you would do is you would pick a sample, maybe out of... Actually, let's change these numbers around. Let's change this around. So let's say you have 20 female, 80 male. Now, that's out of your population. So your population is 100. 20 female, 80 male. So that is your proportion, 20 to 80. Now, let's say you wanted a sample of that. You would end up... And let's say your sample is 10 people. You would pick 2 female and 8 male, because you're keeping that proportion going down. Yes, your sample is small, it's pretty small compared to 100, but the proportions are maintained. This could be the same with 70-30. That case, you'd have 7 male, 3 female, and so on. Now, biased is the final one, and as it says in the name, it's where you pick a sample based on personal preference, I guess, or something that skews your sample. So let's say you're in your classroom. I'm sorry, we've been using a lot of classroom analogies today, but I find it a very good way of representing this. So let's say you are this dot here, and your friends are these people here. Your best friends, they're your 3 best friends, right? And they're all there. Bias sampling is basically saying, okay, I want a sample, I'm gonna pick my friends. I'm picking these 3 here. Because I don't know, because I like them, it'll make me more comfortable. But that is biased. You're not picking this person here because you prefer this person here. That is biased. Now, I hope this all made sense. The best thing to do is just practice. Think of real life scenarios. I find that often helps. But yeah, good luck.